Here at the outset of this tutorial, I'm just assuming that you've already downloaded Jamovi and that you played around a little bit with it while you were doing your reading yesterday. So my purpose today is not to show you everything that the reading did, but I will show you some of the things that were in the reading because I think it might be a little easier to see it in action than it was to kind of see it in just written form. But also I want to show you a few things that weren't in the reading. It's important that you recognize and understand that a lot of the things you're learning right now are not going to be specific to Jamovi only, but they're going to be kind of generic things that apply to any statistical analysis package. And so even if you choose not to use Jamovi through the rest of your career, you're going to find that these same principles are often true of other programs like SAS or SPSS. And many of them, of course, can be used in R because Jamovi is kind of a superficial, GUI face that overlays over the R, the power of the R analytics program. And so some of the features that we'll learn through the term you'll see are syntax-based, and therefore you're going to have to learn a little bit of coding, but a lot of what we do here in the course will be kind of point and click and relatively easy to pick up. So one of the first things that I want you to do with me is go to the Modules button up here in the top right corner and click on that Modules, and I want you to go to the Jamovi library. Now, in the Jamovi library, they have a lot of additional packages that you can install that give Jamovi a greater functionality, and we'll add some of these throughout the term. But here at the outset, there's one in particular that's useful for this particular class because of the textbook that we're using, and that is, I've already installed it, so it's going to be under my installed packages, and that is here where it says Learning Statistics with Jamovi. If you install that button, I'm going to go back over to the available. You can click where it says Install, find the right package and click Install. Then once you have it, it will give you all of the, as it says, data sets that accompany the book that we're using for learning in this term. That's going to be really convenient for you because instead of having to download and open each file individually, they're going to be all embedded within your copy of Jamovi. And so whenever you have an example that the book is kind of walking through, you can just open up that same example and walk through it too, really fast and easy. There's a couple of other packages that the chapter recommended downloading. I downloaded the scatterplot package. You can or not right now. Whenever you're ready, you can download it, but we'll be using it eventually. I'm going to hide this window and show you what happens when you've downloaded the data sets that are specific to our textbook. So after that, you can go over here to this menu and click the it's like the little hamburger thing. So click that menu and go to Open. And then in the what you've got here is it will either show up as this PC, that kind of files that you can open from your own computer, or you can click on this data library, and the data library will have in it. You might not see this window right away. If you see this first, anyway, if you see this first, what you'll recognize is that there's a couple of data files that are already embedded to every copy of Jamovi, but then we downloaded this file right here, Learning Statistics with Jamovi. These are the data files that we'll be using for the course. So if you click on that, it opens up a long list of a bunch of files that you might be using at some point during the course. Now, for the purposes of this little video here, I'm just going to click on this file that's called Awesome. And once you click on that, you'll see that it opens up a new data set that's 10 cases. The ID numbers are given 1 through 10, and then it also has some scores listed next to it and what group people were in this particular example. You see there's 5 A's and 5 B's. Now, before I do anything with these data, I just want to give you again, an overview of some of the things that the textbook went through yesterday. So the first thing we need to understand is that there's two views here. There's the data view and the analyses view. When you are in the Analyses tab, it gives you options for the different kinds of statistics you can run. These names should all be familiar to you because you've taken an introductory statistics class. But we're not going to start here. We're going to go first to the Data tab. When you go to the Data tab, this allows you to manipulate your data set. It also allows you to add some metadata, which means the data about the data. So metadata would be things like the variable names, the variable labels, some descriptions about them, what kind of variable it is, and stuff like that. Now, as the textbook said, you can access that by either pushing the Setup button or by double-clicking on the column header. So if you, like I'm highlighted here within the variable called ID, if I click Setup, what that does is opens up a new window for me here, or a new menu up at the top that tells me the name of this variable is ID, and I can add in here some different things. I can say, for instance, that a description of this variable could be participant ID number. And that gives me just a little bit more information. Now, ID is usually a pretty transparent variable name, but sometimes, like if I am fielding a survey, then I might just say that the variable name is question 1.1, and unless I remember exactly what question 1.1 said, I'm not going to be able to analyze those data. So you could put the question wording in this description box. Now, underneath that, you've got also some descriptions of the different kinds of variables that exist. Jamovi tries to make a guess about what the variable type is, and it sometimes gets it right, but sometimes not. In this case, it assumed that the variable type was a nominal variable, which means that each of these values, 1 through 10, are different categories. Like maybe things like number 1 might be hamburger, number 2 might be pizza, number 3 might be tacos, and number 4 might be, just different kinds of food. That, of course, is incorrect. We know that this is a participant ID number, and so what we need to help Jamovi recognize is that this is an ID, and we click that there, which kind of removes the possibility of analyzing this variable in a lot of the ways that other variables can be analyzed. Jamovi, by telling it that this is an ID, you're kind of telling it, I don't ever want to compute the mean or median of this variable because that wouldn't make sense. Even though these look like numbers on a number line, that's not really what's going on here. These are kind of like the same as names. Like if we had number 1 was, Dr. James, and number 2 was Celia Robinson, and number 3 was, Jack Jones or whatever, then that's basically what we're doing here, and so we want to just make sure that Jamovi knows that. Now, you can also say the data type. Of course, in this situation, these are integers. The reason why we can say that is because each of these is a whole number, not a decimal. You could also call them text, and it would treat these numbers as if they were letters, like text, rather than numbers. But I'm just going to leave it as integer for now. I'm going to come over here and click on the next variable, scores, and you'll see that the menu up here at the top changed. You can also navigate across these menus by clicking the arrows to the right or the left. If you see there, I've got the ID again, and if I click here, then I've got the scores back. Now, these scores are some variable in our study. This would be the dependent variable. Or the measured variable. I don't know exactly what these represent at this point. I haven't, read about the details of this particular study, but let's just assume for a second that these are reaction times that somebody took in order to complete a task. So let's put that description here. Time taken to complete the task. Now, we can leave this as continuous. Jamovi made a good guess here that this is, in fact, a continuous variable. The way we know that is, if we look at the amount of time that's taken, you can see that we're measuring in partial seconds. And so, like, we could, carry this out multiple decimal places. And these are not ordinal variables, because ordinal would be like ranked, but you couldn't trust that the distance between each number is the same as every other distance. They're not nominal variables because each of these is represented on a number line, not a separate category of something, and it's certainly not ID numbers. We already talked about what IDs are. We're going to leave these as decimal values rather than changing it to integer or text, and I think we're finished with all the things that we need here. But if we go on to the group variable, this is the most interesting one because this allows us to have different levels of the variable. Now, in this particular situation, we have to recognize that group is the IV, the independent variable. It's going to be the thing that is manipulated by the study designer. Now, in some situations, this might be a quasi-independent variable like gender, where you're not actually manipulating it. In other situations, it's going to be a true independent variable, one that the experimenter has control over, like he might make people come into a room with dim light or a room with bright light or something like that. But just for ease, let's call this gender, and so we'll just say that this is participants gender. And we've got two levels here. We're going to rename A as male and rename B as female. And what that's done is it's taken the original values of A and B, and it's given us kind of like a superficial marker over the top of it. And as soon as I finished labeling what those were, you can see that it changed the actual like what we see in the spreadsheet here. But what's represented in Jamovi underlying this superficial name of male is actually the value A. And you could do the same thing if the values here were 1s and 2s or 0s and 1s or whatever they were. Whatever value is in this variable, you could put a label over the top of it to remind you of what that thing is. This, of course, is represented as text, and it is a nominal variable because these are categories that represent different things in the world that can't be ordered. One's not better than the other, or something like that, higher or lower, or something like that. When you're finished with the metadata here, you can click this arrow to hide it, and then resume with whatever else you need to do. At this point, I want to show you some of these other icons up here. Of course, you've got cut, copy, and paste, which are very familiar to you, I'm sure. You've got undo and redo in case you make a mistake or need to redo something that you've undone. And we just looked at setup, which is that variable view. But there are other things that you can do here with these other icons that I want to show you. Now, let's imagine that, as I said a minute ago, that these are scores. These scores are times in seconds. Let's say that we wanted to transmit this into a new unit of measurement and make it minutes instead. In order to do that, we could come here on the scores and click Compute. Now that would open up a new computation window that would allow us in this new column C that just appeared to take the value of scores, and what I'm putting here is that it's asking for the computation it wants me to make, and it gives me the equal sign saying whatever this new variable currently it's called C, but we can call it whatever we want. This new variable is going to be equal to, and what I wanted to say is scores, because that's what this variable here is called, scores, and then I'm going to divide it by 60. And the reason I'm doing that is because there are 60 seconds in a minute, and so if I divide the seconds by 60, then this will give me how many minutes there were. So I'm going to say time 2. I'm going to say this is time participants time in minutes. And as you can see down here, now what this is telling me is this person took about 1/10 of a minute. This person took nearly 1/5 of a minute, nearly 1/5. I guess this is closer to 1/6. Anyway, each of these is telling me the number of units in minutes. When you're finished computing, you can hide that variable, hide that metadata, and the time to variable remains in your data set. These values here cannot be altered. Like if I try to write over it, it will tell me an error down here. The column is not editable because computed columns can't be changed. If I wanted to type over the top of this one, like put 8 instead, it would allow me to make that change, and the computed value would also change accordingly, because this is still going to be whatever is in scores divided by 60. I'm going to undo that because I don't want to actually make that change, but you can see the principle of the matter. Now, there's another thing you can do here, which is to transform variables. We're not going to deal with that right now, but when we later on need to check some of our statistical assumptions and make alterations to the variables based on based on various computations, we can take a variable like scores and we can do something to it. We can use these different kinds of transformations that I'll show you later on in the course. I'm gonna again hide that, and then you can see there's other options. Oh, actually, I want to delete this column right here that just entered for me. I don't actually want that, so I'm going to come up here and just demonstrate that this delete function will get rid of that whole column. And now we're back to what we had before. You can also add in a new variable. You can insert it in the middle where you are, or you can append it to the end of the data set. You can insert computed variables. You can insert transformed variables, which is what just happened when I clicked on compute and transform. It automatically inserted a new column for me in those cases. But if I didn't have, if I wanted to hand enter new data, then I could come up here and I could insert a column here and hand enter values of whatever they are. I just made those up. Okay, since I'm not really interested in keeping those values, I'm just going to go ahead and delete that column. You can also filter variables in your data set, or the way that what I mean to say is you can filter cases based on variables in your data set. So for instance, if I only wanted to look at those individuals in my data set who had times that were less than 10 seconds, then I could click on this filter function, and it's saying what is the qualification in order to keep them in the data set. And I'm going to say if scores is less than 10, and then I push enter, and it will keep only those values that are less than 10. Now, that doesn't leave me very much to work with, so I might decide instead I'm going to use those values greater than 10 and push enter, and you can see that it just filters out those three values there. If I wanted it to be those values that were greater than or equal to, so that it would retain this value of 10, then I would just write greater than or equal to 10, and you can see that it actually includes 10 now. In my qualification statement. So this is pretty intuitive, but this is following the R scripting format, and so if you're ever unsure of how to write your filters, then you just need to Google filtering in R and just kind of look up the syntax for creating a filter in R, and you use that same filtering schema here. If you go ahead and leave that filter on, then whatever analyses you do, if you go ahead and hide that, it retains that filtering process. And when you go over to your analyses, whatever analyses you do will only be performed on those values that are greater than or equal to 10, and will ignore those that are less than 10. You might want to do this, for instance, if you had extreme outliers that were absurdly high or absurdly low, and you might not want to delete the cases entirely, but you might want to just remove them from certain analyses as appropriate. So I'm going to go ahead and turn off that filter. The way we do that is just kind of click this X right here in the corner, remove filter, and then it gives me back my original data set. I can hide that, and then go over to the analysis, because that we've dealt with everything else that we need to understand here in the data tab. So now I'm going to show you some of the analysis tab. In the analysis tab, we can, I'm going to start just today with some basic exploration. These are descriptive statistics. I'm not going to click on any of these other inferential statistics because we're going to be doing those throughout the rest of the term. But here, if we start with this exploration tab, we can run some descriptive statistics. You probably won't see this scatter plot or Pareto chart because those were downloaded in that new package that I added that you may or may not have added. And so that scatter package, that phrase right here that you see is indicating that those two packages or those two functions appeared with the new package that I downloaded. But descriptives will appear for everybody. So if you click on this descriptives, what you'll see is it pulls up a new window pane. And this new window is giving you instead of seeing your original data, it gives you a list of the variables that were in your original data set. So remember, you had an ID variable, a scores, a time to, and a group. Those are your 4 variables. And it's asking you, what do you want to run descriptives on? Which of the variables do you want to run them on? So I could say, I want to know what is the average score, for instance. So I take scores and I just click it over here into the variables box. And automatically what you see happen over here in the output window is that your descriptives are run for you. You have a mean of 10.9. You have a median of 11.2, a minimum, the lowest score of 6.4, the maximum or highest score was 14.5. Now let's say that that wasn't everything we wanted to know. We also wanted some additional information. The way we would get that is by clicking on this drop down here for statistics, and we could specify additional information that we want. Say we wanted the mode. What's the most common value? Here you'd see that it gives you the mode of 6.4, but it also has a little A next to it, which indicates that there's more than one mode. And the reason why it says that is because every value in this data set was actually only reported once, and so there are 10 modes, because there was no value that was repeated more than once. That's essentially a meaningless value, so I'm going to take that out. If I uncheck that, automatically the mode disappears from my output window. So this is updating in real time, giving me the analyses that I want as I ask for them. You might also want, say, standard deviation or variance, your range, which is the maximum minus the minimum, a range of 8.1. You can ask for all kinds of things, or if you ask for something you don't want, you can uncheck it, like I said. Now, I'm going to kind of clear out some of these things because I don't want all of that to bog us down as I look at a couple of additional functions here. We have other variables that we can use as variables to report descriptives on. Like, for instance, if I wanted to know how many minutes people were taking, I could ask for that to go over here in the variables list as well. And you'd see that it gives me now a mean for scores as 10.9 seconds and a mean for the time in minutes as 0.18. If I wanted to take that back out, I would just click on it and then remove it from that box back to the other side of the variable list. Another thing I can do is I can take my grouping variable, which was, remember, males and females, or A and B, and I can take that grouping and I can put it in here in the split by box. And what that allows me to do is to compute an average, a mean, and standard deviation, or median, or whatever I'm asking for, by the 2 different groups. It splits them. So it's taking my scores in seconds, and it's giving me, over here in the feed out, a mean for males as 9.26 and a mean for females as 12.5. It's giving me a median for males as 10 and a median for females as 12.9. So you can see that that's a really impressive functionality, that you can split things, like you can split your descriptive statistics by different groups and see what the differences are. You can also ask for different plots down here. If you click this drop-down arrow, you can look at the different types of plots that are available. You can, for instance, you could select a histogram. This is going to plot me 2 different histograms, one for males and one for females, but that might be a little overkill since I only have 5 of each. And instead, maybe what I want is to remove the group from my analysis and just give it let it give me one histogram. Now you can see that the histogram makes it appear like some people scored, like if you look at the density right here is saying the frequency with which people are getting these values, and so it gives you a value here and a value here, here, and it's saying how many people. Well, it looks like one person got this, one person got this, 2 people got this, but we just said a minute ago that there was no repeated score in the data set. So why is it telling me that 2 people got this value right here? Well, the reason it looks like that is because the histogram is using some kind of smart statistics, just some guesses, to bin together multiple values in a single category. And so it's saying, like, between, I don't know what the values are, but let's say it's like between 10.1 and 11, we're going to say anybody that got in that range, we're going to call within this bin. And so it's been 2 scores 2 times within this bar, even though they didn't get the exact same value. We've just put them together in that category. A bar plot wouldn't be very useful in this situation unless we get the groups back, but if we like I'll show you for a second. If I unselect my histogram and I select a bar plot, what this is going to average, and what this is going to give me is the average of all the people in this group, and it's just going to show me one bar that's the average of all the scores. But that doesn't make a lot of sense. Instead, we might want to add our grouping variable back in, and will give me an average for each of the two groups. So it'll show me males versus females with their averages and 95% confidence interval as the error bars around it. You can play around with other kinds of requests here if you want to, but that's the primary thing that I wanted to show you here in our in this orientation. Another couple just really brief things. If you end up exiting out of your descriptives, to suggest that you are done with what you were doing, and then you go back in to say you wanted to like run some more descriptives, you would just come again to exploration descriptives, and this time it would give you a new output window. Say I wanted to run not only my my bar plot by males and females, but I also wanted something that was overall. Like I wanted the scores reported overall without being split here, and I wanted a bar plot that was overall without being split. Then I could ask for this new updated additional analysis that would keep everything aggregated instead of split out. If I exit out of here by mistake and I actually wanted to edit this analysis to update it with, oh, say I actually needed the range here included too, then I could double click on that analysis that I want to update, and I can just request my range to be added to the mix. And when I'm finished, I just exit out and it updates that analysis for me so I don't have to redo the whole thing. Another thing I want to show you is how to hand enter data that you might have collected using like a paper and pencil method, or using a different data source that you need to put into Jamovi because it isn't already in a spreadsheet format. If that were the case, if you're hand entering data, I'm just going to come up here and select a new spreadsheet so that I can start afresh without some analyses done for me, or without some data already filtered in for me. Let's imagine that I have already kind of organized these data for myself in Microsoft Word. Here's my table that shows a research situation where I've tracked how many miles male shoppers are going in a day and how long it takes them to go that far, and how many miles of female shoppers are going in a day and how long it takes them to do that. And so whilst going through the mall, the men, it appears, are probably walking a little bit less than the females. You can see just eyeballing it, these are higher numbers than these on average, and the time that they're taking seems to be less than the females as well. And so if my hypotheses bear out, then if I did some analyses here, I should see that the average distance and the average times are less for males than they are for females. Now, if I wanted to take this and just copy and paste it into Jamovi, that wouldn't really work for me, because notice I've got multiple kinds of headers here. I've got males going a certain distance, males going a certain time, females of a certain distance, females of a certain time. So what I have to do is recognize that when I'm setting up my data in Jamovi, I can't put it in the same way that I might put it into a table for reporting in a publication. Instead, I would have to put distance as a single column, as a variable. I would have to put time as another column, as another variable. And then I would have to use an additional variable to demark who were males and who were females, just like you saw in the last data set that we were just playing with. So here in this situation, I might copy and paste this distance and time into Jamovi, and that would be variables A and B. I'm going to copy and paste these, and I'm going to have them continue on. They're also going to be variables A and B, because this is distance and time as well. So now what I've got is 10 distances and 10 times, and I just need to tell that the first 5 are males and the second 5 are females. So I might do this by marking the first 5 as 1s and the second 5 as 2s. And then, if I wanted to give Jamovi a little bit of information so I don't forget what these variables are, then I would go over to the Data tab. I would go to Setup, and I would say, this C variable is actually something I'm going to call gender. And I'm just going to leave it a nominal variable. I'm going to call the ones males and the twos females. When I'm finished with that, I'm going to click over to go back to column B, and I'm going to remind myself that these are the these are the times. Column B's are the times. And the description here is going to be that these are the times spent shopping at the mall. And of course, this is not a nominal variable. These are not levels. 15 does not represent some category like hamburgers, and 22 represent hot dogs. These are continuous. These are currently being measured as integers, but it would be fine if we called it a decimal value too, if we wanted to change this to be representing partial minutes instead. I'm just going to leave it as integers though. If I click this previous variable arrow, then it will again take me to variable A, and if we recall, these represent distances that were traveled during the shopping day. I can call this distance, and then instead of times spent shopping at the mall, I can call this distance traveled while shopping at the mall in miles. And I'm going to leave this as a continuous variable. I'm going to leave it as decimal, and if I just push enter, then this will save the information for me. And now I have a data set that's properly formatted and ready to use for analyses that we might want to do. If we go over to our analysis tab, actually I'll just close this first, go over to our analysis tab and click exploration, descriptives. Again, we can request the different kinds of variables here, like distance and times. I've highlighted both of those by holding down the Shift button. You can carry both of them over at the same time to your variables column. You can split them by gender, and you can see, as I predicted, that the mean distance traveled by males is less than the mean distance traveled by females, and the mean time spent by males is far less than the mean time spent by females. So that gives us kind of an indication of where inferential statistic might lean if we were to run a t-test, for instance, on these variables. And that, my friends, is all I needed to show you for today. If you have any questions, please reach out and let me know.